Well, if you did not watch last class, like the video on the Moodle, you need to go back and watch that, okay? You're probably going to be in the weeds to start this class, okay? You can get caught up, and then I say start because we're going to finish the last chapter, and then we'll start the new chapter. You'll be okay on the new chapter, all right? Let's go ahead. Whatever you're doing notes with, get it out. You need them. So, all right. We did some dilutions, right? We finished up with that. And, okay, now we're going to go into other unit. This is unit 3.4 in your textbook, other units of concentration. So we've been discussing molarity, right? That's number of moles per liter of an aqueous solution, right? Moles per liter. We can easily convert that to number of particles, right? Because a mole equals 3.14 times 10 to the 22nd particles. We can easily convert that to like an amount of mass of it. I need to make sure this isn't buzzing. I'm sorry for that. Because I know if I have 1 mole, well, 1 mole of a certain substance has a certain mass. I can tell you how many grams of something. So we can convert those things. We had problems with it. Now we're going to look at other things other than moles per liter. Okay. Here we do things like, have you ever heard of like parts per million? That's a thing. You need, if there's X number of parts per million of lead in your water, then like the government will shut down the public water. There's X number of parts per million that are allowed for chlorine before it becomes, or iodine before it's considered dangerous to you. One of the ways that they look at this is something called mass percentage. So let's write this down. So our theme, number 1 of these is mass percentage. If you want to give this a title, I don't know how you arrange your notes. I'm always big on titles, so I like to know where I'm at. But I guess I would write here other what? Other units for the solution concentration. I guess I'll just tell you up front which ones they're going to be. We're going to look at mass percentage. We're going to look at volume percentage. And then we'll finish up with parts per million. It's always abbreviated ppm, parts per million. So it's just kind of a roadmap of what we're doing here. All right. So we'll get started on mass percentage. All right, mass percentage. Say mass of solute over the mass of solvent. We are times 100%. So we are assuming aqueous solutions here. That means solutions of things in water. And so a solute and a solvent forms a solution. The solvent is the one that's in greater quantity. Almost always it's going to be water. And the solute is whatever is dissolved in it, right? So if I have salt water that I'm gargling with, my solute is salt, and my solvent is water. Kool-Aid, my 2 solutes are sugar and cancer-causing stuff or whatever, I don't know, whatever that color stuff is that my wife won't let my kids have. They can't even have like Otter Pops. Like I grew up on, it's like, now they have them like, you know, like fake ones, but it's like a plastic tube, which is, you know, dangerous because you get all these parts per million of plastic in you, and it's just colored sugar water, and you freeze it, and you know, we just ate those like crazy. My kids, they'll probably never have one. Anyway, I bought ring pops for them. You know what ring pops are? Yeah, I had to throw those away. I know. Just did it. They've been wanting those things, and like, it has red dye. I can't get it to you. It'll kill me. Anyway, so mass of solute divided by mass of solvent times 100%. Let's do just a practice one. So I've got 100 grams of salt water, and of that total, I had put in 10 grams of salt. I kept this super easy, right? Look at this math. You can do this math. So I just want to know what is the mass percentage of salt for this, right? So I take the mass of the solute, which is 10 grams, right? And I divide that by the mass of the solvent, which is 100 grams, right? And I can do this. That's like 1/10. That's 10%.
I think you messed up on that. That's a solvent, not solution.
Thank you. I did mess that up. Appreciate that. This should say solution. So I've got 10 grams of my solute, which is my salt, and I've got 10 grams of my solution, right? And then I multiply this by 100%, and I get 10%, right? That's easy. We can do that all day long. Now we're going to do things with that, okay? Okay. Let's get mathy with it. 5-gram sample of spinal fluid. So I'm going to write down the particulars here. 5 grams of spinal fluid. That sounds wonderful to think about, doesn't it?
No.
5-gram sample of, 5.0 gram sample. I better put my, see, I'm bad about significant figures, but we're supposed to be keeping track of these things. 5-gram solution of spinal fluid contains 3.75 milligrams of glucose. Okay? What is the percent by mass of the glucose? Okay? So this is easy. This is the same thing, but in word form, right? So I take my solute, dissolve it by my solution, and I multiply it by 100. So what's my solute here? Glucose. How much? 3.75. Now it does say milligrams, so I'm going to do something right with that, right? And then I'm going to divide it by 5.0 grams. But how do I go from grams to milligrams or milligrams to grams? Multiply by 1,000. So I could do that, right? I could do this another way also. But I'll just do it this way. This is easy. 1,000 milligrams per gram, right? That takes care of it. These will cancel out, and that'll put it into milligrams. So if I were to simplify that, I would just say 3.0, and I got to do it times 100, right? Times 100%. So when I do that, and I want to simplify, I get 3.75 milligrams over 5,000 milligrams, right? Times 100. And what do you get? I can also, I don't need to go crazy simplifying everything, but you could just take 3.75 divided by 50. It would work too. So what do you get? Good. Means that I did it right. 0.075%, right? That is the correct answer. Do you guys get that same answer? Okay, good.
Oh, okay.
I like the O's.
Yeah,
That's
no, I
good.
tried to multiply by 100. That was like,
Okay.
I'm a couple zeros off, but yeah.
No worries. Okay. Let's do another one that's similar to it. A ball of tile cleanser contains 135 grams of HCl, hydrochloric acid. By the way, do you understand that hydrochloric acid is dangerous?
Yes.
You don't want to play with that stuff. If you're ever in the store and they sell something called muriatic acid, that is hydrochloric acid. So So you can buy that at like Lowe's and Home Depot. It'll be titled muriatic acid. You can clean tile, you can clean grout. You can remove the grout with hydrochloric acid. You just pour hydrochloric, I've done it when I've had to remove tile and stuff. Just pour hydrochloric acid over it and let it sit for a little while. It'll be gone. It'll also destroy your clothes, your skin, blind you. You gotta be careful.
Do not touch it.
So, 135 grams of hydrochloric acid, and what it says. And 775 grams of water. So they did this one differently, right? This time I have my solute and my solvent, but they did not give me my grams of solution. To do that, I gotta be a little savvy and realize like, oh, I gotta add these two together, right? So let's add them together, and what does that tell me for my solution?
910 grams.
910 grams of solution. Good. Okay. So the question is, what percent mass is the hydrochloric acid, right? So how do I set this up? What's my formula? I don't want numbers, by the way. I just want a formula. Solute. Mass of solute over mass of solvent.
No, mass of
Or solution, thank you, times 100%, right? So you can see it. So that's going to be 135 grams over 910 grams times 100%. And what do you get? 14.83. 84?
Yeah.
Percent. Okay. How do y'all feel? Everybody get that same number?
Yeah.
Awesome. We're doing good. Okay. That is the right answer. Okay. Next one. Concentrated hydrochloric acid. So this is an industrial term, right? So if you're in the business and they say concentrated, this is what they mean. This is probably what you can count on in muriatic acid, though I haven't looked at it to confirm, because I never knew there was quite this industrial standard. But it says concentrated hydrochloric acid is an aqueous solution of 37.2% HCl by mass, and it is commonly used as a laboratory reagent. The density of this solution is 1.19 grams per milliliter. What mass of HCl is contained in 0.5 liters of the solution? So I want to know how much HCl in grams do I have in 0.500 liters of solution? Okay, so I'm going to have to convert some things. And what am I looking for? Grams. But what can I start with? Liters. This is what I start with. So let's do this. I don't want numbers yet. Okay. I want to go solution. Let me redo that. Volume of solution. Okay. I want to end over here with solute in mass. Okay, does that make sense? I'm going to begin with this. I want to get to this. So I've got some things in between. I've got percents. So I can figure out maybe like how much of this solution, what volume of it is that. I've got a density that'll let me get from volume to grams as a conversion, right? So where should I start? Begin volume. I want to get to mass.
How many grams is the solution?
Sure. But what's my first step?
You need to transform the density into that amount of volume.
I would say.
I actually think that's going to be my last step.
Actually, you would need to figure out what amount of liters the hydrochloric acid is?
Yes. So I've got my volume of solution. So what I can do is I can multiply using this, right? So volume of solution here, I need to cancel out volumes of solution because I need volume of solute, because this is what I'm dealing with. So I'm going to put volume of solute here, and I'm going to put volume of solution down here, right? These will cancel out. Now I'm dealing with volume of solute, and my density will let me get from volume of solute to the mass of the solute, right?
So hang on, the volume of solution at the bottom will make it to where that won't work.
No, that's not true. Hang out a minute. So I've got my volume of solute, right? Which is what I want. Isn't that what I'm looking for? Is how much of the solute?
Yes, but if
So-
those both canceled out, then,
I'm left with this on top.
yeah, but then you're
But now I'm
not.
going to do something with this. I'm going to do this with it, right? Density of this thing is 1.19 grams per milliliter. So that's mass over volume. So I've got mass of solute over volume of solute. So these will cancel. These will cancel. That will leave me with this, which is exactly what I'm looking for. I want to show you this conceptually, like the steps of how to do one of these problems before I plug any numbers in. If you do, this is the one great thing about chemistry, okay, and the math of chemistry. The math is never hard. It's just a matter of steps. If you can get everything to cancel out, then you know you're right. As long as you plug it into your calculator, right? You know what I mean? So my volumes of solution are going to cancel. My volumes of solute are going to cancel. It's going to leave me with massive solute, which is what I'm looking for. So let's plug that in. My volume of solution is 0.500 liters, right? I'm going to say solution. And I'm going to multiply that by this percent situation, right? So I've got 37.2 out of 100, right? And this is in liters. I can keep this in liters. It doesn't matter what I have this in. I can do liters. It's just fine. 37.2 liters of solute. This is of solution. So right now I'm dealing with liters of solute. Now I need to multiply that by this density, right? So I need 1.19 grams of solute over 1 milliliter of solvent. But I do have a problem, right? Because this is in liters, this is in milliliters. How do I convert, how do I make my milliliters into liters? What's the relationship between a milliliter and a liter? Yeah, but this is, I'm going from milliliters to liters, so I don't multiply, I've got to divide. So I've actually got to do this, right? Well, I can flip that, right? I can use the reciprocal of this. I could just multiply it out here, or I could come down here and I could just go, hey, it's 0.001, right? Because that's the same equivalent, right? 1 over 1,000 is 0.001. So when you plug this into your calculator, you go 0.500 times 37.2 divided by 100 times 1.19 divided by 1,000, and that's going to give me my number, right? So plug that in. We'll see what we get.
See, in a test, would you have to do it that way, or could you just like figure it out yourself? Or like, would you have to follow the steps you just get?
I'm going to posit to you that if you don't follow the steps, you're probably not going to figure it out. You're going to get lost. Or at least it's going to take you so long you won't finish the test.
Okay.
Now, that's not to say that every now and again you won't just figure it out because you can't remember. Because that's how it goes. I've reversed engineered an equation plenty of times in my life. About half the time I get it right, about half the time I get it wrong.
Okay.
But you're going to do, the key thing here to know that you're getting the right answer is that you track these.
Yeah.
I mean, you could reverse this or whatever, yes, but if you don't ultimately have these steps, you're not going to get the right answer.
So I'm pretty sure this would be easier to say in scientific notation.
Love it in scientific notation. What do you got?
Okay, so 2.21 times 10
I don't think you have the right answer.
I got 221.34.
221.34?
Yeah.
Just that's it?
Yeah.
Okay. 221.34 period. Let me see if that's the correct answer.
to, okay, I don't know what I did wrong.
You got some zeros off somewhere. Because you had the same digits, you just had the wrong number of zeros. Which is why you always do it at least twice, and if you get the same answer twice, good. If not, you do it a third time. Always. It would suck to get all this right and then miss a chunk at the end. All right. So far, so good? Okay. Let's erase all this.
So I got the exact same answer.
You're doing something wrong.
I did the exact math that you had on the board.
We got 1, 2, 3, 4, 5, 6 people. 5 out of 6 got the answer, and you got the other one. So something's wrong.
I can see that.
Okay, well, we're not going to fight it right now. Okay, last one, what was the answer on the last one? 221, okay. Okay, so now we have a question. It's using the same kind of thing. It says, what volume of the same HCl solution contains 125 grams of HCl? So we need to write some of our numbers that we just had there before, right? So what was my percentage concentration? 37.2. Okay, so 37.2% HCl by mass. All right, and the other thing that we had was density, right? Density equals 1.19 grams per milliliter. Okay, good. All right. So now we want to know what, or wait, I can't spell. What volume of HCl solution contains 125 grams of HCl? What am I going to start with? I'm going to start with what I'm given, right? I've got mass. I've got mass of what?
HCl.
HCl. So mass of solute, right? And what's it asking me for? I want, what do I want over here? Volume of solution, right? Okay. So I'm trying to go from mass of solute to volume of solution. Mass of solute. What can I do with this?
So funny thing is, I already have the answer.
Well, don't tell me. What can I do with my mass of solute to start me on a path to get to volume of solution? I've either got to right away, I've got to get from mass to volume, or I've got to get from my solute to my solution, right? Because I had to make both those changes along the way, right?
Do you have to cancel out the grams, so multiply it by something over,
I would say for the density first.
Say it again?
For the density first.
Okay. What was your question?
Because are we kind of solving it similar to the last one?
It's going to be somewhat similar, yeah.
So would you need to cancel out the mass? Does that make sense? Like, yeah, with the solid.
I think we will, but I think you're safest to probably begin here.
Okay.
I need to get from massive solute to massive solution. And then I can start doing some other stuff. So I can multiply that by my percentage, right? So I know in this case, I can go, I've got solute on top here, I need solute on the bottom. So I could do 37.2 grams of solute. And I could do up here 100 grams of solution. And now I've got massive solution, right? Now I just need to get from massive solution to volume of solution. What lets me do that? The answer is density, right? So I just multiply that by my density, right? And so I've got massive solution on top. I need to cancel that out, so I need it on the bottom, right? So grams of solution I need down here. Well, that number is 1.19, right? 1.19 grams of solution, which means up top I need per 1 milliliter of solvent, or I'm sorry, of solution. My solutes will cancel, my massive solution will cancel, and I'll be left with a volume of solution, which is exactly what I want. So if I run these numbers again, or run this formula again, I go 125 grams of solute times 100 grams of solution over 37.2 grams of solute. Solute's going to cancel. Everything else here is pretty much going to remain the same as what we wrote. And what do you get for an answer?
$282.37.
That's right. 282 milliliters of solution. Come over here and work on this side while you guys are finishing that up. All right. We doing okay? Thumbs up if you got that one. Okay, good. All right. Let's do the next one here. This is now using volume percentage. It's basically the same. Okay. It says here, rubbing alcohol is usually sold as a 70% aqueous solution. So, rubbing alcohol. That's my solution. It's 70% ethanol, no, I'm sorry, isopropyl. Isopropyl alcohol by volume. Okay. So if I had a volume of 100 milliliters of rubbing alcohol, how many milliliters of that are isopropyl alcohol? 70, right? If I had 10, then 7 of them. Okay, but this isn't going to be that simple. That's too easy. So, that said, the density equals 0.785 grams per milliliter for isopropyl. Okay. How many grams of isopropyl alcohol are present in 355 milliliters of rubbing alcohol? So I want to know how many grams isopropyl are present in 0.785 grams per milliliter. Okay? So, what do I begin with? I've got to begin with what I'm given. What do I start with?
This.
We're going to use that. That's going to be a convert, like to convert from one thing to another. But I'm looking for this, and I'm given this. I got to start with what I'm given, and I got to finish with what I'm trying to get. So I begin with 0.785. What did I just do there? I wrote something wrong. No wonder you said density, sorry. 300. I'm so sorry. Wow, it gave you a density. How many grams of isopropyl alcohol are present in 355 milliliters of solution?
So the volume.
Yes, I'm going to begin with volume. So it's not 0.785. I'm going to begin with
355.
355, but I'm not going to do that because first I want to write out like the concept of this formula. So I'm going to begin with volume of my solution, right? And I want to end with mass of my solvent, right? So I get from volume to mass. I can do that by using my percentage, and I can use it by my density, right? So I've got a volume of solution. What's going to be the easiest thing to convert right away?
The percentage.
I don't think so.
2 grams.
I think it's going to be easiest to, oh, I'm sorry. You said the right thing in a way I wasn't expecting. Yes. So I'm going to go from volume of solution, and I'm going to try to get to volume of the solute, right? So volume of solute over volume of solution. Okay, that's going to cancel. Now I've got my volume of solute. I just need to get my mass of solute. To do that, I just need to use density, right? So I will go volume of solute on the bottom over the mass of the solute. This should say solute. I'm giving you my answer. So go ahead and plug those numbers in. Okay, it's in a different color. What'd you get for an answer?
195.07.
195.07. What'd you guys get?
87.
We get that, something different? I'm gonna run it myself just so. 355 times 0.7 divided by 0.785. No, 355 times 0.7 divided by 0.785. We get 316. What did I do?
I think you inverted the last one. put mass over volume, and the last one he flipped it into volume.
I did. And I did it on purpose, but I did the wrong thing on purpose. Okay, so I need 0.785 grams over 1 milliliter. Okay, so let me try that. Didn't read my own labels. .195.07. Is that the right answer? Let's double check. It is. Okay. How are we doing? That's good. Okay. Well, let's do the next one. Okay. Wine is approximately 12% ethanol by volume. Okay. Ethanol has a molar mass of 46.06 grams per mole. Okay, now it wants me to, and it's giving me a density, it's giving me a lot of information. And a density of 0.789 grams per milliliter. How many moles of ethanol are present in 750 milliliter wine bottle? So I want to know the number of moles ethanol in a 750 milliliter bottle of wine. So what am I given? And what am I finding? Given the volume of the wine, I need the number of moles of ethanol. So I've got to go from volume of my solution, and I need to find out the number of moles of my solute. So I've got stuff that's going to hopefully begin letting me get down the line to this, right? So I've got a volume here. I can figure out if I can go from the volume of my solution to the volume of my solute, right? By using this, right? So let's go ahead and just set it up that way. Volume of solution needs to go on bottom. Volume of solvent is going to go on top, right? Once I have the volume of my solvent, I can get to what? I can get to the grams of my solvent using my density. So I'm going to go from here, I'm going to put volume of solvent on bottom, or solution. No? Solute. Thank you. Volume of solute on bottom, and up here I'm going to get mass of solute. Okay? And then I need to have one more conversion, right? If I have the mass of the solute, I can get to the number of moles of solute by converting by that. I've got mass of solute on bottom, and I can put the mass, or excuse me, I can put the moles of solute on top. That will get me moles of solute, right? So plug those numbers in. There it is. Lost? Okay, let's do it. So what's the volume of my solution?
750.
750. Okay. What is, keep in mind this here, right? 12% ethanol. So my wine's going to need to go down here, right? My ethanol is going to need to go up here. It's 12%, 12 particles of ethanol for every 100 of wine, right? Okay. All right. This is in milliliters also, right? Okay, good. Now I'm going to come over here and I'm going to use my density. So my density says I have how many milliliters of ethanol, or how many grams of ethanol per milliliter, I should say. 0.789 grams of ethanol for every 1 milliliter of ethanol, right? So now I'm in grams of ethanol. Now all I have to do is convert to my molar mass, and I do that using this. So it's 1 mole of ethanol for every 46.06 grams of ethanol, right? Now let me make sure everything cancels. My milliliters of wine cancel, my milliliters of ethanol cancel, my grams of ethanol cancel. I'm left with 1 mole, or I'm left with moles of ethanol. And what's that answer? 1.54? We have a different answer. But you get the same answer. Anybody else do it? You're working on it. Let me know what you get. I'll do it too. $750 times 12 divided by 100 times.
Were you supposed to make the 12% into a 0.12?
Give me 1 second. So we did. Because what's 12 divided by 100? It's 0.12. I could have written this just as easily. I could have done 0.12 milliliters per 1 milliliter. These are the exact same thing. Go about it whichever way you want. Remember, percent means per 100.
Yeah.
So that I did 12 per 100. That's just how I did it.
I got the same thing though, is that right or is it not?
You got the same answer at the end?
Yeah.
Yeah, that's the right answer.
Oh, okay.
Yeah. If you did 0.12 over 1, that's the exact same as 12 over 100. You would get the same, and we could have done 120 over 1,000. It would, as long as that ratio comes out the same, we're good. You good, brother? Awesome. Okay. Okay, did that one. We're almost done with this. Praise the Lord. I am tired of doing it. According to the EPA, when the concentration of lead in tap water reaches 15 parts per billion, certain remedial actions must be taken. First thing it asks you is, what is this in parts per million? So I've got 15 parts per billion, convert that to parts per million. Parts per billion, put in millions, is going to be so 1 million. Think about this. 1 million is this, right? Also known as 1 times 10 to the, say 6. Good. Parts per billion. also known as 1 times 10 to the
Nine.
ninth, right? A billion is. But if we're saying parts per billion, this is actually 10 to the negative 6, then, or million is 10 to the negative 6, per billion is 1 times 10 to the negative ninth. So when I say 15 parts per billion, what I am saying is 15 of these. It's 15 times 10 to the negative ninth. I want to know what that is in parts per million.
Multiplied by 1,000.
Multiplied by 1,000?
Divided by
Divided by 1,000. Right. So, go ahead, what do you get?
0.5.
Equals 0.015 parts per million. There's another way. I wrote this in these in exponential notation or scientific notation, right? But the difference between these is 1,000. It's that simple. So if I had 1 at a billion, that would be 1,000th of a million, right? $15 billion over 1,000 is going to give me 0.015. That's the first component to this. The second component here is this. Remember, I got 15 parts per billion, and it says, what's the, okay, this concentration, what mass of lead would be contained in a typical glass of water? So if I have 300 milliliters of H2O, how much lead in grams? So I am given this. I want to find this. I've got to do some conversions in between, right? So I've got 300 milliliters of H2O, or let's say a solution. Given volume of solution, I want to find mass solute, right? Okay. Given a conversion factor, right, with 15 parts per billion, if I've got a certain solution, I can tell me how many parts of that are, or what ratio of that is going to be lead, right? So what do I do? Is this how they solved it? With this. Is that how I solved it? Yeah.
Volume of solution versus volume of solvent.
Say it again.
The volume of solute for the volume of solvent.
Yeah, I want my solute on top. I want my solution on the bottom. Right, now I need to get from volume to mass, right? How do I do that?
We don't need like conversion, like grams to milliliters.
Yes, I'm sitting here looking at this problem going, what's going on here?
I feel like you're missing something.
I do too. Let me have a second here. According to the data, concentration of lead in tap water is 15 parts per million. Concentration. At this concentration, what mass of lead would be contained? Let's do. I got a volume of solution, I've got a volume of solute, right? This parts per billion is in mass, isn't it?
No, actually, I think it could be, I think it might be volume. Yeah, parts per billion would be volume.
Get that one. Definition of parts per billion unit may be used to calculate the requested mass if the mass of the solution is provided. Since the volume of the solution is 300 milliliters is given, its density must be used to derive the corresponding mass, assuming the density of tap water to be roughly the same as pure water. So there it is. So we're going to go mass of solvent. Sorry, solute. Mass of solution. Mass of solution over volume of solution, that's my density, right? So now I've got mass of solution, and now I can, is that all I need? Assume the density of tap water is roughly the same as that of pure water. Since the concentrations of any dissolved substances should not be very large, rearranging the equation, defining parts per billion unit, and substituting the given quantities yields. Parts per billion equals blah, blah, blah. Oh my goodness. Yeah, this is a mess. You're just sitting here watching me. It's okay.
Well, I'm gonna.
Let's go to the next part.
I'm gonna do what I think the man thinks.
Okay.
And,
Take another run at it.
let me know if I get the right answer.
Let me take another run at this. I've got 300 milliliters of water, right? I'm trying to get the amount of I know out of this, I can get to mass very easily, right? So I can go 1 ml, 1 gram in water, so that'll get me to grams. I know that 15% of that, or I'm sorry, 1.5 part per billion. So I'm going to do grams over 15 grams. That's my 15 parts per billion, right? That's going to. This was in water. This is water. This is also in water. This gets me to lead. This was water. So my lead is going to, everything's going to cancel out. I'm going to get to my lead, which is what I should get to. So 300 times 15 divided by a billion ought to be what my answer is. Even if it took me way too long to get there. 300 times 15 divided by 100.
Where's that on the page?
1, 2, 3, 1, 2, 3. You're not going to need it. It's going to be 4.5 times 10 to the 1, 2, 3, 4, 5th, negative 5th. Is that the correct answer?
Yeah.
It's saying 4.5 times 10 to the negative 6th, so I clearly have done something wrong.
That's what, yeah.
You got to the negative 6th?
Yeah.
Okay, so I either counted wrong or punched something in wrong. But that is how you do that one, right? So you do have to presume the density of water. I would not do that to you. That's just dirty. If I need you to know that, I'm going to put that in the information you need, okay? 300 milliliters of water, I'm going to get from milliliters of water to grams of water. Then I can get from grams of water to grams of lead, which is what I'm looking for. I do apologize for that. What time do we have? Okay. We're going to begin the next section. It'll be nice to be on to something new for a little bit. So that finished up your instruction for the chapter on molarity. I'm going to assign some problems from your book, okay, and I will have it set up as like homework quizzes where you do it and you type the answer in, and it'll let you know if you're right or you're wrong. You know, if you're off by, you know, you got a 0 in the wrong place or whatever, just go retake that quiz and put the, you know, just make sure you know how to do it. And you're going to need the practice, because these are what the problems are going to look like on the test. One day in class, rifling through these is good, but it's not sufficient to then, in a week or two, suddenly have it on a test. It's going to be lost, right? It's going to be left behind. So we've got to get the repetition. All right, new subject. We're going to begin tackling what's called stoichiometry, but the first thing we need to do in tackling any of that is learning to write balanced chemical equations, right? So we're going to write balancing chemical equations. That's where we're at. For example, CH4. You ever heard of CH4? It's methane gas. Like, scientists don't want us eating as much beef because cows are farting this stuff. And it's supposed to be an ozone gas and all this kind of stuff. But at any rate, the combustion of propane gas. When I talk about combustion, what am I saying? What's it going to do?
Break down.
Not break down. It's going to burn. It's going to go boom. Okay? So to burn something, what gas must it have?
Oxygen.
Oxygen. Must have oxygen. So CH4 plus O2, right? When I do this, whenever I have a combustion reaction, whenever you do any kind of a gasoline or a carbohydrate, you're going to get two products as long as it's burned perfectly, okay? Your two products are, another problem they don't like, one is CO2 gas, and the other one is?
Water.
Water. Okay, so the combustion of methane gas with oxygen produces carbon dioxide gas and water vapor, okay? Simple formula, but that's not right. What's wrong with this right now?
Right now, it is not balanced.
It's not balanced. By the way, these are called reactants.
The others are called products.
Yes, and these are called products. You must know that. Reactants and products. I need to balance my reactant. The law of conservation of mass says that I have to have the same number of particles on both sides. Have to. Well, I don't. Look how many hydrogens I have over here. 4. How many do I have over here? 2. That doesn't work. So this is where you begin just kind of playing around. If I've got 4 over here, I need 4 over here. What do I need to do to try to make that happen? Multiply by 2. So let me see here. If I put 2 there, how many oxygens do I have now on this side?
4.
I have 2, and 2 is 4. How many do I have over here? So I'm not balanced still. What do I need to do? Multiply by 2. Now let's look at it. I got 1 carbon, 1 carbon. 4 hydrogens, 4 hydrogens. 4 oxygens, 2 and 2 is 4. That's a balanced chemical equation. There are other ways that we can do this. You can literally like keep track of them. Here I've got carbon, hydrogen, and oxygen, right? I can trace them through my products and my reactants, right? So let's go reactants and products. So I've got 1 carbon. I've got 4 hydrogens, 1, 2, 3, 4. I've got 4 oxygens, 1, 2, 3, 4. I'm looking for the same thing over here. I got 2 so far of oxygen. I've got 1 so far of carbon. I've got 4 hydrogens, 1, 2, 3, 4, and I've got 2 more oxygens. And so I can see that that's balanced. I know I'm good, right? Learning to balance chemical equations is very, very important. This happens a lot. This is a whole lot of what we do around here. And then we do things with it, like, let's do another one. Let's see. Okay. Let's do hydrolysis of water. So I've got water. If I juice water with some electricity, do you know that I get gases coming off?
Yeah.
Yeah. What gases come off? You should be able to see it just from looking at it.
Hydrogen and oxygen.
Hydrogen and oxygen. So, hydrogen is a gas. How many electrons does hydrogen have?
One.
It has one. Is it going to exist like that? No, it's going to pair immediately with itself. It's a diatomic molecule, a diatomic gas. So it's always going to exist as H2. In the same way, oxygen is always going to exist as O2, right? And we're talking about pure oxygen. So,
Except when it's in the also with
all right. So let's go here. I want to keep track of these, my products and my reactants. All right, so I've got my hydrogen, and I've got my oxygen, I've got my reactants, and I've got my products. So, how many hydrogens do I have here? Two. How many oxygens do I have here? One. How many hydrogens do I have here? Two. How many oxygens do I have here? Two. So we have a problem. That doesn't work. I can't just create an oxygen. So to deal with the fact that I have two oxygens over here, what do I have to do over here?
Multiply by 2.
To multiply by 2 to balance it. When I do that, how many hydrogens do I have? Four. How many oxygens do I have? 2. Life's good. Over here I still have 2 and 2. I have another problem, right? I have too many hydrogens over here compared to here. How do I balance that? Multiply by 2. Right? And now when I do that, this goes up here and life's good. Everything comes together. Let's do another. Write the balanced chemical equation for the reaction of molecular nitrogen and molecular oxygen. So N2 plus O2 produces N2O5. Okay. Take a stab at it. What you guys got? Doing good? So when I look at this, I go, okay, I got 5 oxygens over here. All right, well, that's going to be hard to get. I know 5 and 2 are going to come out to 10, so let me try 5 over here, right? Which means now I've got 10. Well, if I got 10 here, I need 10 here, so I got to put a 2 in front. If I got a 2 in front of this, that's a total of 4, so I need 2 here. I can also go back and I can do this the long way. I can go nitrogen and oxygen, right? Products and reactants. I started off with 2 and with 2. Over here I had 2, but there I had 5. 1, 2, 3, 4, 5. So I'm going to multiply that joker by 5, which is going to bring me up to 10. So 2, 2, 2, 1, 2, 3, 4 here. Well, now I'm going to put 1, 2, 3, 4 here, right, by doubling this, which meant I doubled that. So now that goes up to 4. I got to balance that with this, gets me up to 4, and now I know that I'm good. Okay. All right. Let's try another one. Write a balanced equation for the decomposition of ammonium nitrate to form molecular nitrogen, molecular oxygen, and water. Okay. So we're doing ammonium nitrate. That's NH4NO3. Okay. This thing decomposes. In other words, it just breaks apart into some stuff. It breaks apart into nitrogen gas, and into oxygen gas, and into water. Okay? Let's play with that. I look at this, I'm looking at these, I know these hydrogens stick out to me right away. I know I got at least double this, right? When I do that, it means I've got 2 oxygens here and 2 oxygens here. Oh, I got nitrogen gas here. I got 2 here and 1 here. I got at least double this. I'm gonna try that. When I do that, I got 2 nitrogens. That's good. I've got 8 hydrogens. Okay, so this can't be 2. This has to be what?
4.
Has to be 4, because I've got 8 here. The only place I can get them from is over here. Okay? So let me try it again. I got 2 nitrogens, both sides. I've got, oh, I messed up.
No, that is.
No, well, it might end up being correct, but I forgot that I've got another nitrogen here. Move back out of that. Let's try that again. I got 2 nitrogens here. I got 2 nitrogens here. I got 4 hydrogens here. I've only got 2 here, so I'm going to try this. Let me do it in blue. I've got 3 oxygens. That's weird. I got 4 and I got 2. That doesn't work, right? What do you want me to try?
4.
4 what?
4 of the first one.
Here? Here. You like 4 here? What does that do for me?
Now you have.
See how we can balance it. So if I have 4 here, that's actually 8 total nitrogens, right? So I've got 2 times 4, that would balance, right? So my nitrogens would look good. Okay? Let's try my hydrogens next. I got 4 times 4 is 16. How many do I have? I've got 2, so this has to be 8. Okay? Well, that would be 8 oxygens. So how many oxygens do I have over here? I got 4 times 3 is 12. Here I've got 8. So that leaves 4. I have 2, so what do I have to do to this one? Double it.
That is balanced, but it's
Balanced.
definitely not the correct answer.
You're sure about that?
Because all of those can be divided by 2.
They can all be divided by 2, so I can make this simpler. Very good. So let's simplify this. He's making a point. This is balanced, but it's not right. Okay? To make it right, I've got to, instead of having these 2s and 4s, I've got to have 1s and 2s. So this would be 2. This would be 2. This is just 1. And this is just 4. It should still balance, right? I've got 4 nitrogens, I got 4 nitrogens. I've got 8 hydrogens, I've got 8 hydrogens. I've got 6 oxygens, I've got 4 and 2 is 6 oxygens. So let's compare that to the known answer and see what it says. It says that you were correct. That is the right balance equation, right? And it's not unusual to get something like this, or even sometimes you get a fraction. If I had a fraction here, I'm going to have to multiply, right, by the denominator to make it whole numbers. When I'm over by 2 or 3 times as much, I've got to divide to make it balanced. Okay. What time is it? Do I have time for one more? I really don't. Okay. All right. Let me pray. You know we need prayer, right? Me, you, all of us. Father, help us with these things. That what we've just learned and gone over, help us to retain it. Be diligent in studying it. Let it stick with us. For your glory, we pray in Jesus' name. Amen. All right. God bless you all.